I think Ilham Mustafa is here. Uh, can you just confirm once, Ilham, if you can see my screen and listen, like hear my voice? Hello? Uh, I think Ilham is not paying attention, maybe. But I think my voice should be audible. I am unmute here. Good. Mm, I'll wait for 5:10, not 5:10, maybe. Yeah, so we'll start in a couple of minutes. Uh, Sanjay, can you hear me? Hello? Hmm. No one is responding. I don't know. Oh, somebody replied, yes, audible. Okay, cool. So it's 7:05, so we'll start now. So yeah, welcome everybody for this class on uh, you know on the subject of principles of industrial engineering. This is regarding the 6th week of the course and what was the content that was discussed. So as usual, we'll start with some brief recap and in between we will take the questions that are important in this chapter or in this course content. So basically, first part that was discussed was regarding material handling. So as the name suggests, uh, it is essentially a part of an organization where movement of different sorts of materials is studied. So uh, if you can just remember that uh, first of all, uh, you know uh, this material handling aspect, it does not directly affect your this thing, your profits or loss, but it is one of those things which is not directly seen when you are working in an organization or factory. So in that case, this material handling is like that backbone of your production system. So it involves material handling, storage, and other sorts of activities related to this. And it is not it is actually a uh, very deeply studied field of research also, because it is one of those factors which is, if not considered properly, it will result in substantial amount of losses and you'll not be able to figure out why. So essentially, sometimes what happens in, let's say, in a factory or workshop, uh, you design the production line or the workshop capacity, assuming certain machine capacities that you put. So, but in the end, you realize that the machines are working fine. There are no major breakdowns there, but still your production output is low. So it is not always for very obvious reasons. Sometimes this material handling aspects are not considered. So basically, the raw material that is required for the production line is not properly stored, or maybe it is not properly handled, or it is not properly uh, brought to the first stage of production line. And similarly, during the course of production line, the materials are not properly handled, so there is a lot of wastage, scrap production, or there are some quality issues because the material handling is not proper. Reasons can be many for this. uh, Maybe workers are not properly trained, or even workers are trained, the layout of the factory shop itself is not proper. Maybe some environmental issues, maybe some health concerns, like maybe if there is a common flu or something like that. So if people are not aware of these important aspects of material handling, etc., uh, uh, their production is doomed to be lower, and therefore this is an important aspect for uh, any organization. I'll give you one example that I personally was involved with. In one of the production line, the last usually towards the end of the production line, there is a packaging unit. So whatever product you are making, finally it is packed in a proper aesthetic manner, so that it appeals to the customer base by highlighting the important features, etc. So towards the end, there was a packaging unit. So for example, let's say in that production line, let's say 100 units were produced in a minute. It was a very fast moving production line, and it was like, let's say, example of soaps. So 100 units of common soaps, like that we usually use for bathing, etc. That was produced on that production line, and towards the end of the line, there was a packaging unit. So the thing is that packaging unit was fully automated, because it is not possible for a human to pack, to put a packet on, let's say 100 units of soap in 1 minute for 8 hours of a shift. So that is humanly impossible. So the logical solution was automation. It was automated, but indeed, when we analyzed data for a week or so, we observed that one of the major downtime is a time when your system is not operating, your production line is not operating. So there are many reasons for downtimes. So what happens in a well organized production system is, first of all, we try to avoid breakdowns or downtimes, but sometimes it is inevitable. So during that phase, we write down why this breakdown happened or why this downtime was observed. So dedicated person is there in the production field for these data collection things. So we analyzed that data, and we observed we were facing problem that our line was designed for 120 units per minute, but we were actually producing 100 units per minute only. So first we thought maybe it is the bottleneck is somewhere up, initial stages, because initial stages were big, like 1 ton of batch was produced, and then that batch was divided into small 100 grams of units of soaps. But in the end, we realized that major chunk of the downtime was coming from the packaging unit. So it was puzzling for me, because I always assumed that packaging is fully automated, so there should not be enough, room for downtimes there. But what was happening was, for packaging, you need rolls, right? Big rolls over which this wrapping material is wrapped, and you put that in machine, and machine automatically then consumes it. So machine was also working at full capacity, but what was happening was the size of the rolls that were required for that machine. They were huge. So one roll was around 25-30 kgs. So and that roll was put in the machine, which was at height of, let's say, 2 meters. So for a single human which was operating the packaging unit, it was very tedious, because imagine you have to lift, let's say, 25-30 kgs of weight from ground to a height of 2 meters all alone, and with minimum time. So what was happening was, the rolls were too heavy, and the height up to which the rolls were lifted, for a human being it was tedious, because usually packaging line is given to older workers, because there is not much to do there. So yeah, so coming back to our topic of discussion, so that's where material handling is coming into the picture in this whole whole production system. So finally we figured out some solutions for that. We ordered rolls of smaller weight, but there the problem was, earlier in one shift you have to change the rolls 2 times. So if you assume that changing a roll takes, let's say, 5 minutes for a worker, earlier in 8 hour of shift, 10 minutes were going because of roll changing. But if you reduce the mass of roll, let's say, by half, then you'll have to shift, you have to put 4 rolls. That the time may be reduced to 2-3 minutes, but eventually it was same only. So in the end, we realized the major problem is lifting the loads from the ground to the top. So finally, we put some system in which the rolls were stored at that height only, where it was supposed to be put, and that's how the time was reduced. So I think like from 10 minutes, it was brought down to 2 minutes or something like that. So that's what material handling means. So this was one of the examples that I faced. Usually, it is different for different type of industry. For production line, there may be one sort of problems that can be dealt with by the proper material handling system. For batch or product type of sorry process type of industries, there will be different challenges, but in the end you have to consider material handling as an important concept. So there are scientific ways to do that, but for this course briefly it was discussed, like not quantitatively but qualitatively it was discussed. So the objective basically is to reduce. Can anybody help me out here? What what are the objectives that are coming to your mind when I say that material handling is important? What can be the objectives? Can anybody start off the discussion? I'll wait for some time. I think we have one more attendee. One second. Oh, we have uh, Jagat. Jagat. Am I taking and pronouncing the name correctly? Jagat Rachugan. Can anybody tell anything? If you are not able to speak, you can type in the message also. I think Ilham typed some time back.
Labor
If
charge.
yeah, one second. I could not hear you. Can you speak slightly louder? Sanjay, I think. Yeah.
Sanjay Sajjanwar, sir.
Yes, sir. Tell me.
Material handling is important to reduce the labor charge, labor charge, you can say simply.
Okay, so let's say cost. Cost in
Cost
labor,
handling.
labor, raw material, etc. Uh, Delays, because
Yeah, delays.
let's say if you have a raw material which is very far from your production line, it is not a good design, right? It should be as close to your production line as possible. Then more can be extent of movement. As give my personal example just some time back, it is highly important parameter to consider from a employee's point of view. As a manager or a factory manager, you may not realize that extent of movement is that important, but it is important. We should consider that also. And then one more important aspect is, I mean, space requirement is there. If your systems are properly optimized from material handling point of view, space requirements will also go down. So you'll utilize your factory floor area more efficiently. But one more important is very important consideration is accidents, or not accident is maybe considered as a very critical term, but safety hazards. So most of you might know that in any workshop or any factory, safety should be, and most of the time is considered as a topmost priority. So what happens, for example, if you have a flammable raw material and you're putting it somewhere, very far from your production line, so there is a chance, uh, if you are bringing that flammable raw material from the storehouse or the inventory to the factory line, but in between there are machines, there are laborers, and there are weather factors also. What if it is too hot that day? What if it is too windy that day? Though, so this safety aspect is also very important, and usually it is considered in a good organization. So as I told you earlier, it is this material handling aspect is does like it doesn't directly deal with your production output, but indirectly in the backside it affects that. So that is why we study this part. Otherwise, somebody may wonder why we are studying material handling. Is it so important? It is because see, material handling system, if it is efficiently designed, you will have like right amount of raw material at right time, at right place available, and you know it will it will eventually lead to increase in production as well as since we are listing down the reductions, you can say reduce wastage also, because uh, if it is a very smooth operation, if everybody knows, from where to get that material, at what time you need to get that material, if those things are clear for all, then the production line will be running smoothly and there will be less wastage. And essentially, when it is like, as the common sense suggests, if wastage is less, the useful production is more, and if that is what the objective is on the shop floor. So that is about why we consider material handling. Then there are different ways to do that. The most common is, like, let's say equipments. I'll put equipments for material handling. So this MH is acronym for material handling. So essentially, can somebody tell me what is the common material handling equipment is seen everywhere? Let's say in any many organizations. Anybody?
Forklifts are generally used.
Pardon?
Forklifts, forklift,
Yeah, forklifts are there, and
cranes.
your voice is breaking.
Yes, sir. I say, sir,
Maybe
forklifts.
maybe you can type it out. Will it be possible? Or
Yes, sir.
can you just mute yourself for a second? It is too much noise in the background. Yeah, yeah. So yeah, as you are saying, yeah, cranes, forklifts, those are there. But commonly, conveyors are there, which are very common, because conveyors have a large, range of applications. You can move uh, small mass components as well as bigger components also using conveyors. But usually, for very large, very heavy components, these cranes and forklifts,
Yes, sir.
uh, etc., are used. uh, then coming to the, let's say, if you have a longer distance material handling system in your mind, you can use motor vehicles such as autos, etc., or maybe you can use rails. Railway is very safe mode of material handling as well, because there are no vibrations in on rail roads, as well as I mean, there are less disturbances also. If you had studied railways for luggage transport, it is quite peaceful operation, not compared to the passenger transport. Passenger is a very different case. So yeah, then there are some chutes also. If so, basically chutes are some components in which you use the gravity. So basically, you store materials at some elevated level for whatever may be the reason. Maybe you don't have space on the ground floor, or maybe it is safer to keep it aside because it is flammable or something. And when it is required, you put it to the chutes. So it gravitally, like by using gravity force, it comes down and you use it. So that is also very common, chutes, etc. And other things like uh, rails, ships, etc. So all these, I mean, it depends on which industry you're talking about, but these are the equipments that are used. I think some questions are there. In your assignment, I think they're there. But broadly speaking, there are bulk handling machines, then there are elevating machines, then there are hoisting machines and monorails and etc. So bulk machines like cranes, you know, this thing, uh, forklifts, etc. Uh, Elevating machines will be, mm, I don't know what to call them, but as the name suggests, they move material from one level to the higher levels, or maybe ulta, from top level to the bottom level. Then there are equipments like monorails, which are they are basically fixed paths and fixed defined path with defined movement of direction. So it is not like you can once you put the monorail, you cannot change the path easily. You have to put it again. So basically, for a fixed path, for a fixed direction, these are used. Uh, so wait, that I mean essentially it depends on which industry you're talking about, and based on that, or which product that you're talking about, the size, shape, form of the product, if it is solid or it is liquid or it is gas. So based on this state of the product, physical state of the product, uh, material handling system quite aggressively changes. uh, then important factor is like layout of your floor area, your plant area. Safety is also very important because, as I told you, I think some time back, based on the safety rating of the raw materials, their storage uh, techniques are different. If it is quite flammable or unstable product, it is usually kept far away in a secure place from the this thing from your main factory area, because in any case of unforeseen event, it should not lead to any catastrophe. I remember one time I visited one go down in which this thing this let's say Amazon has this go downs, right? So basically, whenever you order something from your mobile or laptop, order is punched in that this go down where uh, many like different types of products are stored in different places. They have huge racks, and each rack is divided into some you know multiple components, multiple divisions. So on each floor you'll have different types of materials. But what I observed was, in one corner away from all the racks, etc., there was one room. It was air conditioned, so it was not at room temperature. So in that room only these type of products were stored. For example, this body spray, and these things, room fresheners, etc. So these products, which are quite flammable, they are not stored in the same way as that of non-flammable products, because they need special care. And since they are very highly flammable, if you put it, let's say, by negligence, if someone puts the storage unit for body sprays immediately next to the notebooks, so can you imagine the risk that they carry? So that's why, uh, uh, it depends on what type of material is there and what type of safety categories are, safety ratings are associated with that material. Same thing goes for fuels. If you have noticed, in this PSUs, for example, like uh, ONGC, NTPC, IOCL, wherever they use huge amount of fuel for storage, they don't store it, somewhere near to the crowded area or something. They have big storage tanks, and they are usually like our water storage tanks are there, right, at some height. So that's how they store it, because it is a flammable product, and if you store it like uh, without proper care, it may be resulting in some serious hazards or serious accidents also. Sometimes it is stored underground also, because let's say in petrol pumps, it is stored underground because that is the safest place, right? Because there are so many vehicles coming, going, people coming, going. You cannot have storage tank above the ground. First of all, it will take space. You'll have a crowded petrol pump. And second of all, it is not safe also. There are chances of pilferage also in the night. People may steal it also. So, considering all this factor, that's how you design the handling system for your production. Then there are some other factors like ceiling height, structural strength, etc., and those are also important. And finally, as usual, everywhere we consider cost. So, but I think usually in a good organization, safety comes before the cost, and it should be like that. In some organizations, they don't consider this, but they are risking their own business. But yeah, cost is also important. As I mean, as the objective is to maximize the profit, it eventually becomes minimizing the cost for any task in the organization. So this is more or less about material handling systems. There is one more thing that we should consider, the human aspect of it. For example, if it is quite flammable liquid or something like that, usually it is not handled by human. First of all, since it's a flammable liquid and there are chances of hazardous outcomes, usually that type of things are automated. Usually machines handle critical things like that. But uh, and it is good for humans also from their own safety point of view. So and as the logic says, for any material handling system that you design, you should have minimum number of machines involved or minimum number of humans involved, depending on which application you're talking about. Because if you put more man force for a job where it is not required, basically you are increasing the labor cost, and then eventually you'll reduce your productivity, because that manpower could have been used for some other useful outputs. So yeah, so I mean there are some effectiveness parameters also, that how much effective is your material handling system. It can be anything. Usually it is effectiveness. So basically, how much time you spend in handling the material uh, compared to the total production cycle time. Uh, I mean, it may not be a good measure if your production cycle time is very less, but raw material handling time may require more time. It depends which industry you're talking about. So, based on industry to industry, these effectiveness parameter differs. So that is there. I think this is all about material handling. If I can see any question, I'll just briefly get to it. Yeah, there is one question. I'll write it down for people who may go through it later. Uh, Cranes are used. I mean, this is in the context of material handling, so I'll not write everything up to the this thing. Uh, Short distance movement. B option is vertical movement. C option is lifting and lowering. And D option is all of the above. So, Sanjan, can you just quickly tell me what is the answer?
All of the above. D.
Yeah, so that is correct, because I mean cranes can be used on, I mean one of like conveyors and cranes. I mean you can consider forklifts also somewhere there only. These are major material handling systems for a small or localized operation. And if it is a global or like interstate or inter country, that type of or material handling system, then it is a different industry altogether, like transportation industry. So there you have railroads, or like roads, airplanes, ships, etc., etc. So yeah, these type of questions are expected from this part of the syllabus. So I think we can move on to the next topic. uh, I think I've covered most of it regarding the material handling. We'll go to the next topic, which is, one second, I'll just see if I missed anything in this. I think I have not. Just give me a second. Yeah, so material handling is done. Then there is a broad topic which was started in the discussion, which goes by production planning and control. So the short form used is PPC. So this is actually a quite big concept. It is, I mean, the name is small, but it has so many components inside it. So, so basically, there are different stages in PPC. One second before we go there. One second. Yeah, I think for this class we'll discuss this thing only. Uh, till scheduling, till capacity planning, it will be there. But yeah, briefly, if you see PPC, I mean, it is better to just uh, divide it into number of stages and study. So different stages involved in this PPC are, first is planning. So as the name suggests, planning involves all sorts of planning. So again, going further into the classification, this planning itself is divided into two parts. So one will be prior planning, and second, oh, one second. And second is active planning. So see, essentially this sort of segregation is important, because if you don't segregate these things and study them separately, it is very easy to get confused, because this is quite subjective matter, and it varies industry to industry, product to product, even student to student, how they understand these concepts. So therefore, there are different uh, methods to study, and the effective method is to just segregate everything and study them as a unit, and then see the whole picture. And then there is action stage, in which basically you do dispatching, and then there is control stage, in which you basically uh, progress monitoring and corrective action. So these are like broader things that are there in production planning and control. So we'll start with this first thing of planning. See, planning is a quite telling term. So if you just uh, just don't go by the what was taught in the class. Just imagine if I ask you what is planning. So basically, for any event, you anticipate what all possibilities are there, and when you prioritize that, let's say your objective is this much, like let's say for example, if you have a big exam coming up, then you plan for it in a way that first you fix the first you find out the date of exam, then you find out the syllabus for the exam, and then you find out the proper references like notes or books for the exam, or maybe online content. Nowadays it is more often that way only. And then you divide your syllabus into number of days, and then you anticipate that you may forget what you initially studied. Then you keep some days towards the end of the, like towards the close dates to the exam for revision. So basically what you do, you anticipate different outcomes that can happen during the time that you have to prepare for the exam, and you make contingency plan for those activities in order to score good marks in exam. So if you don't have the ambition to score good marks in the exam or for any task, if you don't have, ambition to do well in that task, you will not plan because it's not required there. So for any organization, the objective is to maximize the production of the goods or services at minimum cost, right? That is the whole, I mean, with safety and health considerations for your employees and all, uh, and as well as, legal compliances, environmental compliances, all those things. But in nutshell, you want to maximize your profits, and one way to do is to, increase sales. And if you are planning to increase your sales, you need to produce more, because if you plan to increase your sales and if they do increase, you should have enough supply ready to cater to the consumer base. Otherwise, consumer will go to the competitor. So then it comes down to the this thing, production planning. Now, how do you do production planning? Because it is difficult to do production planning because there are many uncertainties actually. Uh, One example could be, consider an example of a cyclical industry. For example, a cold cold weather cloth making industry. For example, a small business which makes sweaters or these caps and all for winter, or winter shoes, etc., jackets, etc. So for that industry, the demand is cyclical. So you will have more or less some sort of idea uh, from your past experiences that just before the winter, demand picks up because everybody wants to have proper clothing for coming winter. And as the winter passes, the demand goes down, and during summer there is hardly any demand for winter clothes. Uh, and during rainy season also, if it is like not a dual type of clothing, so there is also no demand during rainy season for winter clothes. So accordingly, you plan for your production, and that is a good way to do for cyclical industry. But let's say there is some industry like FMCG, fast moving consumer goods. So their demand is more or less, their baseline is fixed. Uh, if they run some promotional schemes, or if there are some festivals, like Diwali or something, or there are some local events like maybe like elections or something in some states, etc., then these companies will have higher demands. So that's how they also manage. So therefore, these activities which are, you know, just thinking about all the pre-plan, like before, actively doing the planning, what all aspects are there to consider, that comes under this prior planning thing. So if I can write down, I mean, professor has taken most of it concept wise, but I'll just, briefly go through it. Uh, so, prior planning, as the name suggests, it is planning uh, in advance basically. So, what do you plan in advance? First of all, you plan your product design, like what you are going to produce basically. That you have to do prior only. You cannot do later. Or product design or modifications also, you can say. Based on your past data, you realize that there are some feedbacks from the consumers uh, that are genuine feedbacks, and you think you should consider them before, producing new items in future, or new goods in future. So there you need to do modification or development basically. So it is that way. Then for that product, what should be the production strategy? So as we discussed in previous classes, if it is a mass production, then you need to have process layout. If it is a smaller, like not mass, like the volumes are not that high, then you need to go for a product layout. So that type of planning also you need to do beforehand only. Then there is forecasting. So forecasting, as the name suggests, based on the previous year's sales numbers or demand numbers, what you do, you target some growth. So for example, in this year I sold 100 units. So next year I should sell more units, right? Because I want to grow as an organization. It should be always positive outlook. So what you do, you see for past 2 3 years what was the rate of increase in the supply or demand. For example, 2 years back I sold 90 units, and last year I sold 100 units. So you can see there is incremental change of 10 units per year. So if I am forecasting for next year, I should at least forecast for 110 units, right? Because that shows my organization is growing, and that is good sign for everybody. Uh, Whereas, let's say I sold 100 units 2 years back, and last year I could sell only 90 units. So now the forecasting becomes tedious because you need to, forecast it for positive growth, right? So, but your sales are going down. So there, what you do, you go back to your product design uh, aspects. You see the feedback of consumers, and then you figure out why the sales are going down, and then you have to narrow down on the root causes. If it is the fault of the product, you have to modify it. If it is something like, fierce competition is growing in that segment of market. Let's say when a new competitor has arrived and they are providing uh, maybe good quality products as compared to yours. So that could be one important reason for drop in sales. So what you do, first of all, you should increase your quality of your product. Whatever is required for that, you have to do. And if still the sales are not picking up, then you do promotional schemes, like buy one get one free or 10% off, something like that. So that's what this forecasting is not that easy. Uh, I mean, if it is all hunky dory, if your sales are growing and growing, maybe you can say your business is stable and positive looking, and then you can do forecasting in that way. But it becomes highly critical for this cyclical businesses as well as commodity based businesses. Uh, Basically, like for example, if I am a metal processing plant owner, the metal prices are decided by global commodities. It is a global supply chain issue. So it is very hard to predict for next year, or see, short-term predictions are still okay. Next year you can predict for some target, and you can do some course correction in the meanwhile after 3 months or after 6 months. But if it is a long-term projection, let's say for next 5 10 years, then it's a very uncertain sort of prediction that you are doing. But you need some sort of guidance, right? You cannot tell factory workers that produce anything that you want. You need to have some sort of targets. So for that, forecasting is important. But keep in mind that forecasting can go wrong as well uh, in the long term. In the short term, it may be manageable because you have clear idea about what is going to happen in the next year or so. But for example, if you would have planned for, let's say, 10 years in the year 2015, so uh, you could not have foreseen a global event like COVID-19. So whatever forecast that you might have done in 2015, by the time COVID arrived, all those forecasts are basically nullified because they were not done considering COVID. So this is what I'm trying to convince you that long-term forecasting is a very, very highly experienced set of people can do that, who are experts in their domain. They have, let's say, for 20 30 years of experience, and even those guys could not predict COVID. So that's how it goes. It is the nature of that job, and it is like that only. Then there is something like aggregate aggregate planning. So See, you may be wondering, I'm not taking many questions, but whatever I'm discussing here is, it can be one question in it itself. So I'm not going in that depth. So basically, aggregate planning. One second. Yeah, so aggregate planning is like intermediate term of planning. So depending on industry, usually 3 to 12 months of planning. And as the name suggests, you need to have some aggregates. So you need to give some numbers now. So basically, you need to give some numbers on how much volume to be produced, uh, in how much, for that much production, how much raw material you require, and if you produce, like if you require, let's say x units of raw material, uh, how will they be procured, and if you want to produce x amount of units, is your infrastructure suitable for that? So all those things are there. So basically, you can consider aggregate planning as a medium term planning. So you need to, look into material. So you looked, then if you need capex, capital infusion in your business, because if your forecasts are higher, let's say you are anticipating that your demand or sales will grow 10% next year, but you realize that the current production capacity that your organization has can only cater up to 5% increase in the next year. So now that is a problem, because you have a business of 10%, but because of your own constraints, you could only manage 5%. So what you do, you increase your production capacity, and for that you need capital. You need loans or investments, etc., etc. So that depends on what type of industry you are, or what type of organization you are, small, large, uh, all those things. And one important part is labor as well. So materials is there, capital is there, then labor is also important, because what happens, as the time changes, or as the uh, socio-economic status of uh, people who are working in factories or production lines, it changes over the time, and everybody has ambitions. So you need to consider, capital required for their salaries, etc., their health packages, etc., as well as number of labors. If you are increasing your production line capacity, if you are putting additional production line, then you have to hire additional manpower. Or in the opposite case, if your sales are going down, maybe because your product is the current production of the product, let's say your product is in the later stages of its life cycle. We studied this life cycle, right? So during the initial stages, production volume goes up, then it more or less stays there, and towards the end of the life of the product, the production volumes go down. So what you do, you realize that this product is not going to sustain for next 5 years. So gradually, what you do, you don't infuse new capital in the capex into that. You try to salvage whatever assets you can salvage. You have to lay off some customers, labor force also, because of this thing. So usually, what happens if you are going to produce a different product? What you do, you train your current labor force for new skills. But your business itself is going down, then you don't train anyone, because that is also a cost. You just lay off and do the legal things. So that is basically what aggregate planning is. So basically, for medium term of, let's say, 1 year or so, you anticipate fluctuations in supply demand, fluctuations in raw materials, inventories, fluctuations in labor related issues. So that is what aggregate planning involves. Then there is master production schedule. So basically, now from long-term planning, long-term forecasting, you come to the medium aggregate planning, and then there is master scheduling. So now your estimates, like in aggregate planning, you gave rough estimates, right, for a year or so. In master scheduling, what you'll do, you'll divide that into quarters. So, uh, like, let's say you have target of X units in 1 year. What you do, you divide it X by 4. In 4 quarters, you divide 25%. If the supply, if the demand is uniform throughout the year. But usually what happens during the festival season, which is I think fourth quarter in India, September, October, November, December, third, fourth quarter. So towards the end of third quarter, usually sales grow for most of the industries in India. So what you do, if you have target of 100 units, usually people buy towards the end of the year. So in first or second quarter, you may not have good sales, so you may not produce more also. So in your master scheduling, you consider these facts and you divide your work, your plan, your targets accordingly. So basically, this is the short-term planning. So basically, for let's say 1 month or 1 quarter, like that. So now this is what basically master production is. And one more thing is this thing, uh, like materials, like materials requirement planning. So basically, what happens? Uh, Maybe what can I can give an example for this. For example, let's say uh, you have a choice. Uh, you are one second. So, for example, let's say you are procuring two raw materials for your production. Let's call it A and B. So now when you are doing forecasting, you have to do forecast for raw materials also, because as I told you, depending on the industry, raw material cost is very important. This thing, very important consideration. For example, if it is a metals business or commodity-based business, anything like petrol, crude oil, etc., natural gas. So in this case, raw materials are very crucial because their prices are quite fluctuating, and their source of income is source of procurement is also quite fluctuating. So uh, you know, if you want to procure crude oil and you're operating from India, you have so many options. You have option of procuring it from Middle East, then you can procure it from Russia or maybe US. So now depends on the current geopolitical scenario. So all these things you have to consider while doing forecasting. But uh, in let's say you are then you come to the master scheduling. Let's say you're planning for a quarter, and all of a sudden Russia-Ukraine war breaks out. So earlier you might have thought that I'll procure it from Russia, let's say oil, crude oil that I require for my industry. But then that country is going to war, then international things are going on, etc., etc. So the oil there is costly. So Middle East is cheaper. So all these flexibilities should be considered when you are doing this forecasting or aggregate planning or master scheduling. See, in master scheduling it is difficult because it is a 1 month horizon, time horizon. But forecasting or even aggregate planning, they have a longer time frame. So there you should consider a higher room for error in the prediction. So that was the point. Yeah, then this is the prior planning, and as the name suggests, next is the active planning. Now, as the keyword active suggests, this is this thing, uh, what you call, more like direct approach, like uh, you know, 1 second. I mean, this becomes highly localized. This prior planning, it was more or less bigger time frame and bigger horizon. So basically, if you are having 5 plants in your uh, organization, so prior planning will consider all 5 plants, and master scheduling will give all 5 plants their targets, etc. But when active planning is considered, it is highly localized. So basically, you do active planning for a single plant in a go. So you consider one plant and you then do planning for that. So what type of process layout is required or product layout. So this is called as process planning. So then you do routing. Uh, Again, I mean, routing in itself is a broader thing, but essentially, as the name suggests, uh, routing also basically, you know, uh, you have to decide the material handling routes. You have to decide the this thing, labor force utilization routes. So etc. etc. So routing, as the name suggests, uh, it is how to diversify or disperse your resources. Then there is material planning. I think we discussed this, but material planning on a localized scale. So for a plant, like you have a master schedule for a month, then you see, you know, on a week to week basis how much material is to be shifted from the go down to the intermediate inventory, and from that intermediate inventory on a daily basis how much is to be get directly on the production this thing production area. Then there are tool plannings like what as the name suggests, tool basically suggests machines, which type of machine is to be readied. What happens, each machine has this maintenance schedule, so you need to consider backup for those machines which are to be maintained during this period. So etc etc. So tool planning comes there. Then loading and this thing. Loading is basically in your production line. What is the idle time for each machine? It should be as minimum as possible. If efficiency should be as high as possible. For manpower also, your manpower should not be idle for more time. They can have their legal breaks and all, but from whatever is the available time, it should be maximized usage of, like, for production of useful activities. So these things are there in active planning. So I think in this class, in this week, these things were only in greater detail. They were discussed. Then there was this thing, capacity planning. So basically, uh, this forecasting itself involves different stages, and this capacity planning can be considered as one of those this thing, what you call, uh, one of the important factor that is considered. So as I told you some time back, if you have, uh, let's say, you know, you are considering this thing, long-term forecasting or long-term capital planning in this case. So capital, one second, I think I described this already, capital capacity planning, and I gave this example in one of my previous classes also, because I faced this issue. So in one of the uh, plants that I worked, it was a production line. So there were, let's say, five machines in series A, B, C, D, E. So what was happening initially, that line was supposed to produce 100 units per hour or something like that. But eventually what happened, the sales were increasing and the demand was increasing. So after, let's say, 2 3 years, the demand was from that production line, the demand increased from 100 to 150. But the planner, the demander, that the person who was doing this forecasting, he or she missed an important consideration, that the maximum capacity of this production line was 120 only, because it was designed 2 3 years back. uh, and maybe that person was changed in, because people keep on changing jobs nowadays. So the next person did not realize that even if I assign 150 units requirement for this production line, it won't be able to cater to it, right? It can produce maximum 120. So what they should have, like, what that planner should have done is, when he or she was assigning 150 units, at that time only they should have given additional funding to increase the capacity of this line, right? So then only we can cater. But they did not do that. They missed it. So what was happening is, Every week the target was, let's say, 150, but the machine was continuously running. It was not like there was some breakdown or uh, any downtime was there. 1 week the machine was completely running, but still it was not able to produce 150. It produced, let's say, 100, because its maximum capacity is 120, but there are some losses, right? You have to consider the actual capacity was 100 only. So every time that production line was producing 100, and everyone was, the managers and the planners, etc., they were blaming workers that you are not doing your job properly. So it was not that the workers were quite efficient only. It was the flaw of capacity planning team. So that was observed in, like, in some months. And then what they decided was, they reduced the capacity for this line to 100, back to 100, and they planned to put up new production line of 150. So that took some time, but eventually they could cover the demand. So that is how it goes. So capacity planning is very important, and in this also there are two parts: long term and short term. So as the name suggests, you can infer for them in details, because sir has given a lot of material on this. So I think uh, now we can go to questions, because this scheduling and all, I don't know whether this is right time to discuss in this class, because I think it will come next week also. Scheduling, there are many methods of doing scheduling, like some mathematical methods are there. So we'll discuss that later. So for now, uh, let's take some questions. uh, hmm. Yeah, I'll take one question. So basically, I have decided, like, I gave you all the concepts. Okay, so these questions, you may realize now that these questions are not that difficult to answer. So the question is, aggregate production planning is a method to decide. And you have four options as usual: inventory to be carried. Then you have an option of production rate. Then number of workers required. And the fourth option is all of the above. So, I mean, anyone wants to answer this question? Uh, but I think it's quite straightforward. The answer is all of the above, because as we discussed just now, this aggregate planning is basically a short-term planning, medium-term planning, and in which you consider, uh, inventory, which is materials, raw materials, procurement, etc. Uh, this is, this materials requirement planning uh, kind of thing, but for a medium term. Then production rate basically, is to cater to some sort of volumes that are demanded by the public or the consumers. And worker is again labor requirement, etc. So they are all part of aggregate production planning. And earlier question also all of the above. I think today we are considering all of the above only. Anyway, what else is there? Mm, Yeah, maybe. Yeah, this was interesting question. Uh, inventory level satisfies the demand when plant capacity is uh, A option was more than the demand. B option equal to the demand. C option less than demand. D option is does not depend on the demand. So yeah, I think Sanjay, can you answer this question?
The B option will be correct, equal to the demand.
Okay, so the trick is it
Yes,
is
but don't know exact answer because I have not gone through this. But according to me, it will be equal to the demand.
okay. That is one of the correct answers. So it was a slightly tricky question. It has two correct options.
Yes.
So as you said, the equal is also correct and the A option is also correct. Because you can imagine, right? Let's say uh, your your demand is 100 units, uh, but you are producing your. One second. Can you just mute yourself, Sanjay? The background noise is more.
Yes, sir.
So basically, for example, your let's say uh, demand is 100 units, whereas plant capacity is only 80 units. So you cannot cater to the 100 units of demand. So this is not a good option for your organization. Uh, Sanjay, can you mute yourself, please? Because background noise is coming.
Yes, sir, I can see. Okay.
Uh, okay, so if you have, let's say, the option that you said, 100 units. So basically, in this case, you can cater to the 100 units of demand, but the problem is if you have some breakdown or something in your plant,
Yeah.
uh, which you did not plan or you did not see, then this becomes quite risky, right? Because you're cut to cut.
Yes, sir.
So, but if it is, let's say, 120 units, so then even if there is some breakdown and you lose some 20 units of production time, then this is also fine, right? So both, if you have more capacity than the demand, that is fine because you can give, in case of any unforced event, you can uh,
Yes, sir.
cater to the demand. But the drawback in this case is if your demand is more, basically you will have more idle time. So once you produce 100 units, you don't have demand, right? So for like remaining time, your workers will be idle, etc., etc. So your this thing will go down, your efficiency of production and all. So, but for this question, both options are correct. Then, then yeah, there is regarding the long-term capacity planning is difficult due to uncertainty in first option is future demand. Second option is product life cycle changes. Then you have market volatility. Then you have environmental and legal complications. So here also, I mean, if you had listened to my commentary some time back on long-term capital planning, long-term capacity planning, sorry. So basically, let's say by long-term, you mean 5 to 10 years, right? So you cannot predict accurately what can be the future demand, because future demand is dependent on, first of all, your competitors may come in the market. If not, your own product. Uh, Sanjay, can you mute yourself, please? Yeah, so that is there. Maybe competitor comes, or your product itself goes out of, becomes obsolete. For example, uh, nowadays everybody wants smartphones, but there was one time where everybody had a phone or mobile with keypad. So assume in 2005, you are a company owner of, uh, like owner of a company which manufactures mobiles with keypad. So for next 5-10 years, you had done some forecasting. But what happened in recent times? This keypad phones have gone out of fashion, and everybody wants smartphone. The touchpad and all. So that's why the demand in future, you can predict them in Excel sheets or using some tools or something. This Nowadays you can use machine learning or artificial intelligence, but in the end it's just a prediction, and it can go horribly wrong also. So that is why there is uncertainty and it is difficult. Then this product life cycle changes. You may be assuming that this product will be in its mature period for next 5-10 years, but what happens? Competitor comes up with a better product, and this product goes out of the market. So that's also important. That also happens. Then maybe market volatility. So your segment as a whole may face market problems. For example, startup nowadays, they are facing liquidity crunch. So this is not their fault. This is due to volatility in the market. So, and then final and very important, uh, consider an example of a car. So nowadays we are on BS6 standards for pollution control rate, but 10 years back nobody knew. 5 years back, even 5 years back, because we were expecting from BS3 to BS4, then 5 to 6. But considering the pollution, we jumped. The Supreme Court, I think, ordered to jump from 4 to 6 directly. So nobody planned for that. No auto manufacturer, even the big ones like Maruti, Mahindra, and Mahindra. So they also did not plan for this, but they had to adjust themselves. So environmental and legal complications. Legal complications, you can consider the example of GST implementation, because before GST there were so many indirect taxes, and there were many industries which were helping other industries in this tax filing department, because it is quite tedious, right? If you have, let's say, 10 taxes to file every time, you generally gave it as a contract to some other third party, and they used to take care of it. But now GST came, and everything is online. So most of the time, your own organization can handle that without any problem. So that type of changes can also affect your long-term capacity planning. And yeah, let me see if any other questions are there. If not, we can stop also because we are already 1.5 hours. Maybe one more question. Actually, all of the things are more or less covered only. So that's why scheduling and all may be discussed in detail in next class.
Yes, sir.
Yeah. So, do you have any questions, Sanjay, regarding the discussion that we had? Any personal experience to share or something like that?
No, sir, as such, I don't have any question regarding this because uh, I'm not regularly doing this course because of my
Oh,
schedule. Na. Sir,
are you a student or working professional, sir?
a working professional. Actually, I'm a assistant professor, but
Oh,
my schedule is too tight that I have to reach every day at 6:30 in the
oh,
evening,
oh,
and from taking time from that, I have doing these things.
oh, okay, okay. Oh, yeah. Uh,
Whatever
I
I
think,
have gained knowledge from this discussion
yeah, yeah. I
will
mean,
be
yeah, I hope this is
yes, sir.
useful to
Important.
you in some sense. So yeah, I think if not much is there, let me just see what was. Uh, if any important question is there, we'll just take one more. If not, we'll stop. Okay, we'll take this one question and we'll stop now. Uh,
Okay.
so the question is the function of master production schedule, MPS, is first option to plan for material requirements and capacity. Second option is to schedule each activity for production, then to forecast the demand, and last option is to supply products on demand. So, as mostly it happens with most of the MCQ question, two options are outrightly wrong. So, in this question, see the last option to supply products to supply products on demand. That is not the job of master production schedule. That is the job of this thing,
Yes.
sales and all. So this option is out of the picture straight away. To forecast the demand, uh, if the option was to forecast the demand for short term, maybe we could have considered it. But when you use the word forecast, usually it is medium or long term. So master production schedule is basically short term, and that too for a month or so or 1 quarter or so. Then the confusion. Oh, I have written plain. So the confusion is between these two options. First is to plan for material requirements and capacity, and second is to schedule each activity for production. So maybe some student can get confused that MPS is for scheduling each activity for production, but that is not true. MPS is for short-term planning, and by short-term we don't mean day-to-day basis. By short-term it is a monthly or maybe weekly in some industries, but usually monthly or quarterly basis. So if you want to plan each day, that comes under this shift planning or something like that. There is some another keyword for that, but that is not master production schedule. Master production is somewhat, it is not day-to-day basis. It is maybe a week in some cases, or usually month or quarter. So that's why this option is also not correct. And yeah, the final option that remains is to plan for material requirements and capacity. So if here also instead of plan, if the keyword used would have been forecast, then also this option was not correct. But uh, since they have used plan keyword, that is actually correct keyword. So therefore the option uh, first option is correct. So yeah, I think other things students can figure out based on the discussions that we had so far. But sometimes the terminology is slightly tedious, and that's when people get confused. So just try to avoid that, and I think you'll be able to solve any question in this category. Maybe
Yes, sir. It is looks that we have to identify properly.
yeah. So yeah, if you just remember the keyword, you can do better. So yeah, I think now we have discussed almost important part. So we can stop now also. If you have any questions, Sanjay, you can ask, or then otherwise we can
No,
stop.
sir. Till now it is okay. Thank you, sir.
Okay, then. So yeah, then we'll stop and maybe see you next time, next Tuesday.
Thank you. Good night, sir.
Okay. Thank you for the attending and good night. Bye.
Good night, sir.